Hey guys, it's Ms. Johnson here. Thanks for joining us today. We're looking at 6.5 notes, which is analyzing graphs of polynomial functions. Our example up at the top says the percent of the United States population that was foreign born since 1900 can be modeled by the equation given there. P of t is equal to 0.00006t to the third minus 0.007t squared plus 0.05t plus 14. Where t equals 0 is the year 1900. That t is standing for our time. It's representing time there. So t equals 0 is the year 1900, which means that, and then we're looking at the graph decreasing from t equals 5 to t equals 75, and then turning to increase after that. So the points t equals 5 and t equals 75 are called our turning points at the graph. So if we take a look at that, literally it's called a turning point because it's where the graph was going up and is now turning to go back down. Okay, and then it continues to decrease all the way down to the point 75, right about here where t is 75, and the graph turns and goes back up at that point. So now when we're analyzing this graph, when we're taking a look at these polynomial functions, we want to count those turning points, and every time the graph changes a direction, that's going to be a degree of our polynomial. Add to the degree. So that's a note that you could write down there. Every change in direction is another exponent in our function. Or in other words, degree. So if I count those, if I count the turning points here, I have one turning point there, I have an increase there, I have a decrease there, and then I turn and increase again. So the change in direction, here's 1, here's 2, and here's 3. That's where I get my degree of 3 there. Okay, so the degree of the function matches the graph. If we take a look at our terms for today, we've got some other new terms to talk about. The real zeros of a function. Real zeros of a function are where the x values cross the x-axis. So we're looking for the x values where a function crosses the x-axis. Or in other words, that's where y is equal to 0. Those are our real zeros of a function. And then we have two types of turning points there. We have relative maximums. Relative max is just a point where a graph changes from increasing to decreasing. So it was going up, and then it turns to go back down. That gives us our relative max there. And a relative minimum is just a point where a graph changes from decreasing to increasing. So this is a point where it was going down, and then it turns to go back up. So that's our relative minimum. Okay. And then another little thing to note on there, it says relative maximums and relative minimums are also called the turning points. And that's what we were looking at in that first example. So let's take a look at number 1. We want to graph the polynomial function f of x is equal to x to the fourth plus x to the third minus 4x squared minus 4x. And we're going to start by making a table of values. Then it says describe the end behavior. We'll talk about what that looks like. And also determine the number of real zeros that the graph contains. Okay, so if you don't have your calculator out, now's a good time to grab that. You're going to definitely want that when you're calculating these values today. So I've set up the table for you. I've put in the x values for you. You're just going to go through and plug in the x value. So like for negative 2.5, I would take that and I would plug it into my function. And that's going to equal negative 2.5 to the fourth plus negative 2.5 to the third minus 4 times negative 2.5 squared. I'm running out of room here. We'll slide the graph down a little bit. Minus 4 times negative 2.5. Now, remember that in your calculator, you have to put parentheses around your value. Okay, especially here because it's a negative value. So if you don't put parentheses around it, your calculator won't square the negative or take the negative to the fourth power. So go ahead and plug that into your calculator. You're going to have a big long decimal, and we'll just approximate it. That decimal is going to be about 8.4. Okay, about 8.4 for that one. If I plug in the -2, same thing. I'm going to go through and plug it in for the whole thing. So you can type this into your calculator. -2 to the 4th power plus -2 to the 3rd power minus 4 times -2 minus 4, or sorry, -2 squared minus 4 times -2. And when I plug that whole thing into my calculator, you'll notice that it actually should be an equal sign here because you end up with a value of 0. So my value there ends up being 0. Okay. Now I want you to pause the video at this point and see if you can finish out the rest of that table. Plug those values in, or you could plop that function into your y equals menu, and that would help you get some of those values as well. But see if you can finish out the table at this time. All right, so I finished out my table there. Those are the values that I have for my function. The rest of them were -1.3, 0 again, 0.9, and then 0 again, -2.8, -6, -6.6, and 0 again. Okay, you can see that my graph kind of goes up and down. It starts positive, goes down to negative, goes back to positive, goes back down to negative. So I've got some changes going on here in the direction. Now I want to go ahead and put those points on my coordinate plane. If I set up my coordinate plane and I just count by ones here, I can count by ones on my x-axis. That means this is going to be -1. That's a -2, -3, -4. This is a 1, 2, 3, 4. And I'm going to count by ones on my y-axis as well. So that's -1, -2, -3, -4, -5, -6, -7, and -8's a little bit off my graph, but that's okay. And then counting up, I'd go 1, 2, 3, and so on. All right, so let's take a look at these points if I put them on my coordinate plane. So -2.5 and 8.4 is going to be way the heck up here off my graph somewhere. So I know that I've got a point way up off my graph. It's kind of hard to see, and that's okay. It can be off the graph for now. We're going to connect it later. -2 jumps down to 0. So there's a point that I have there. And then -1.5 is at -1.3, so I'm at a point right about there. -1 is at 0, so I'm back up to 0. And then -0.5 is 0.9, so almost to the 1. And then 0 is 0, back to 0. 0.5 is -2.8, so -1, -2, -2.8 would be close to the -3. 1 is -6, all the way down here. 1.5 is -6.6, so I even go down a little bit further, just about halfway or a little more than halfway. And then for -2, I'm back up to 0. Okay, so all these points are kind of crazy, and if we work from left to right and try to connect them, here's kind of what our graph looks like. I know it's coming down from there, and then I'm going to connect my points. Then that's where it turns and goes back up. Then it turns and goes back down and goes all the way down here and turns and comes back up pretty steep there. Now, these are continuing functions. They do have arrows on them, and they do continue and go on and on. Okay, so then the other things that we want to look at with this graph, there's a graph of our function. We also want to talk about the end behavior and to find the number of real zeros. Okay, so if I look at the end behavior, basically what the end behavior is what's happening at the end of the function. Okay, what's happening at the end of the function. So at the negative end of the function, as x goes down to -infinity, I'm increasing. It's going up to +infinity. So that's part of my end behavior. Okay, so as x goes down to -infinity, that's when x is going to the left. And if you need to tell yourself that, that'll work. Okay, left. My y values are going up to +infinity. And again, that means they're going up. And that's what's happening to my function there. Since my function is increasing, that my end behavior is going up to +infinity. For the other side, because that's only half of my end behavior, I need to also look at the other half. So as x goes to the right, or goes to +infinity, again, that means it's going to the right, my y values are also increasing because, again, my function is going up. It goes up in both directions. Okay, so that's how I would describe the end behavior. I need to look at both sides of the graph. What's happening as x goes to the left, what's happening as x goes to the right. And then the only other thing that I'm looking at is how many real zeros there are. And again, those real zeros are where the graph is crossing the x-axis. So if I count them, here's 1, here's 2, here's 3, here's 4. That means there are 4 real zeros. Okay. All right, so I'm gonna go ahead and stop our video at this point. Thanks for watching today. Don't forget to hop back to Schoology and take your Schoology quiz, and we will finish up our notes tomorrow.